Hello my dear students, welcome to the session. Students, in the last class we discussed question number 10 and we will go for now question number 11. So before I go for question number 11, I would like to just give you a small input here. Put a note and write down, okay. The first important point is that suppose you have a network which is excited by a step input. Say this is a capital R U of t. This is the voltage source, okay. These are the terminals across which the input is given to the network. Now, I would like to replace this entire network by, okay, using a single switch operation. Means you already know the definition of this U of t. What is U of t actually here? Step input, what is the definition of it? It is equal to what? 0 for t less than 0 and 1 for t greater than or equal to 0. Yes or no, all of you? So using that, I would like to use the switch, only one switch, not multiple switches, only one switch, without changing the configuration of the network. Just use only one switch and remove this U of t. That means in place of U of t, I am going to place a switch, but only one switch, not multiple switches. Yes or no, all of you? Okay. So this is how I would like to do it now. Now, how can it do it? Because we know that if we can define this entire source value, what is the R of U of t? This R of t, small r of t, let us say here, R of t is equal to 0 for t less than 0 is equal to capital R for t greater than or equal to 0. Yes or no, all of you? Okay. That means here the switching is taking place. Until the switching operation taken place, the input given to the network is what? Actually 0. 0 volt. 0 volt means what? 0 volts refers to what? Short circuit. Okay. Now, once the switching operation is taken place, this is nothing but what? The switching operation is taken place for t greater than or equal to 0. That means at t equal to 0, the switching operation is taken place. Now, the input given to the network is how much? Capital R. Using this information, I would like to use a switching operation here. How do you do that? Okay. What are the various ways you have? Okay. Generally, people think like this, Some people may think like this. Okay. The network is here. Now, I would like to place a switch, something like this. Look at it. Is it correct? Okay. Is it correct? Look at this. The switching operation is placed like this. Is it correct? No, it's not correct. Because for t less than 0, the input given to the system, if you see, since it is open circuit, the current given to the network is 0. But what do you want actually here? It is a voltage source. 0 volt is supposed to be given. It should not be an open circuit. It should be a short circuit across the two terminals of the network. Therefore, this is not valid. So now, how can you place it then? Now, some people may place like this. Some people may give an answer something like this. Look at this. I'll give you the switch position here. I'm just opening the switch. This is a network. This is capital R. Now look at this, all of you. For t less than 0, the switch position is what? Short circuit. Yes, it is a short circuit. Short circuit is given to the network. Therefore, the first condition is satisfied. For t greater than or equal to 0, okay, capital R is given to the network. Therefore, second condition is also satisfied. But there is a problem here. Look at this. For t less than 0, when the switch is in closed condition, of course, the input given to the network is 0 volt, no doubt, but this voltage source is getting short circuited. We already learnt a concept that the voltage source must not be short circuited. Yes or no, all of you? Okay. Current source must not be open circuited. Therefore, this is also wrong. Okay. Mathematically looks like, satisfying this particular condition of the switch position, but practically it is not possible, because when you place a switch across an ideal source, now the source will get damaged, infinite current flows, and the entire circuit will get damaged. Yes or no, all of you? Therefore, this is also not correct. So the two conditions, whatever the ideas sometimes you may get, because people give an answer something like this, either this or that, but those two answers are wrong. But How can you place it? Now, you have to give a short circuit across the network to satisfy the first condition without affecting the source, without, damaging the source. Okay, how can you do that? Look at this, all of you. What I do is I place something like this. Okay, I place a short circuit. Something like this. I put it point A, and then plus minus, this is point B, let us say. This is capital R. Now what is happening here? Look at this. When you place the switch at A, position A, now the input given to the network is what? 0. The first condition is satisfied. Now when you move the switch from A to B at t equal to 0, because at t equal to 0 the disturbance is taking place, or the switching operation is taking place. Therefore, for t greater than or equal to 0, the input given to the network is what? Capital R. I hope you understand the point. So I am using a single switch. Now I am seeing that the source is protected. We are not going to damage the source. We are not going to place any short circuit across it. The solution is simple, that you place a separator, okay, zero resistance wire here. First you connect here, then you move the switch position from A to B. Then obviously the two conditions are satisfied and the source is also protected. I hope you understand now how you can place or replace this step input by a switching operation, a single switch operation. You can use multiple switches, okay, also, that's not a problem, but my objective is to optimize the switches. I do not use multiple switches. I want to use only one switch and meet these conditions. Okay, similarly, now you can do current source. R is equal to capital R U of t. Okay, is a network. Okay, R of t is equal to, what is this now? 0 for t less than 0. Capital R for t greater than or equal to 0. Now this can be replaced by, similarly, you can also use something like this, but the problem here is, okay, for t less than 0, it is open circuit. The current given to the network is what? 0 amperes, no problem. But the current source is getting open circuited. Can you really open this current source? What will happen when the current source is open? When ideal current source is open, then infinite voltage will build across it. We already learned it. Current source must not be opened, voltage source must not be shorted. Okay, so based on that concept, now what I do is, again, I place now the switching position something like this. Look at this. The current source with the value of capital R. Okay. Now I'm placing the current source at some zero resistance point. Okay. At some zero resistance point. This is the network. This is at A. This is at B. Okay. Now I'm going to move the switch from A to B. Okay, in 0 time, t equal to 0, I'm going to move the switch from A to B. Then what is happening here? In the first condition, the current given to the network, because the position of the switch is at A, the current given to the network is how much? 0. The first condition is satisfied. In the second condition, when the switch is moved from A to B, the current given to the network is what? Capital R amperes. Therefore, the second condition is also satisfied. Okay, so this is very, very important. Please note down quickly. Note the two important points. Okay, so I have proven that even if the switching operation is not given, okay, you can even use the step function as a switching operation. Okay, note down that, all of you, quickly. Meanwhile, I just note another problem here. Okay, I give you another problem here, question number 11. After noting down that, you can go for question number 11. Let me draw the circuit here. This is I, this is V. Now, here it is asked to find I of 0 plus, V of 0 plus, d I of 0 plus by dt, dV of 0 plus by dt, okay. Hope I think all of you did with this. Now let's go for question number 11. Is asking I of 0 plus, V of 0 plus, d I of 0 plus by dt. Okay. Now again, there is no switch given. Physically, the switching operation is not given, but step functions are given. When there is a step function, obviously the switching is taking place, right? Just now we have proven. Even in the last example also we have seen. Okay. Now, how do you do this? 0 plus conditions, whenever it is asked, go for step-by-step approach. Step by step. Step 1 is what? Construct t equal to 0 minus. Okay. What is a 40 u of minus t value? It is nothing but 40 into 1 minus u of t. Yes or no? For t is equal to 0 minus, that means t less than 0. T less than 0, its value is how much? T less than 0, u of t is 0. So 1 minus 0, that means 40 volts. Okay, 40 volts. Similarly, 4 into u of t is, okay, it will become what? For t less than 0, its value will become what? 0, but amperes. 0 amperes refers to what? Open circuit. Yes or no, all of you? Okay. Therefore, let me draw that circuit again here quickly. I got an inductor. The capacitor behaves like an open circuit. Yes or no? And this will be a 40 volt. We have already seen. And this is a resistor. This is a resistor. And this is acting like what? Open circuit. We have seen already. Yeah, this inductor is acting like what? Short circuit. Physical inductor is available here. Now let's find what is I of 0 minus. What is V of 0 minus? What is the value here? 5 ohm, 3 ohm. Okay. What is the current I of 0 minus? I of 0 minus is 40 volts divided by 3 plus 5. That is, okay, 8 5 ja, 5 ampere. What is V of 0 minus? Okay, these two are connected in series. You can go for voltage division rule, or else the same current is flowing here. I of 0 minus is 5 into 5. That is 25 volts. Okay. Since I is the current of the inductor, V is the voltage across the capacitor, I can conclude here itself I of 0 plus is nothing but I of 0 minus, nothing but 5 amperes. V of 0 plus is nothing but V of 0 minus, nothing but 25 volts. That's it. So you got the first two questions here. Okay. Now the remaining two need to be determined. Whenever the derivative terms initial conditions of derivative terms are required to determine, usually according to our three-step approach, you remember all of you, we used to consider third step. But I told you already, third step, the difficulty is obtaining the differential equation in terms of the desired quantities itself is a difficult task. That is why, okay, I told you a simple method, particularly when di by dt, where I is the current to the inductor, dv by dt when v is the voltage across the capacitor. I told you a simple formula. What are the formulas we have? Tell me. That is VL of 0 plus by L, and this is IC of 0 plus by C. So VL of 0 plus and IC of 0 plus can be determined from step 2 itself. So without going for step 3, from step 2 itself we can find those two quantities. We already discussed all these things in the last session, and let us now construct step 2. Step 2, construct T equal to 0 plus equivalent. So constructing T equal to 0 plus equivalent is always crucial and critical in the entire initial conditions calculation part. So if you are really good at constructing T equal to 0 plus equivalent circuit, I'm sure that there is nothing, okay, difficulty involved in the entire transient analysis. So one must be really good at, or one must be really expert, okay, in constructing T equal to 0 plus equivalent without taking much time. I'm telling you, okay. So therefore, let us see that T equal to 0 plus means what is this 40 of u of minus t? You already know that 40 into 1 minus u of t. Yes or no? Okay. For t greater than 0, this is 1. 1 minus 1, 0. So 0 volt. 0 volt is nothing but what? Short circuit. And 4 into u of t will become what? 4 ampere. So now let us construct with these inputs the equivalent circuit. Short circuit means it is something like this. Okay. And the resistor remain resistor. And inductor is replaced by, what is that? 5 ampere with parallel inductor model. Understand? Okay. Next, capacitor. Voltage source with a series capacitor model. What do you get here? Resistor. And then you have a current source. What is this? 4 amperes, 5 ohm, and this is 25 volts. Okay, 25 volts. Right. Now this is the capacitor. Your objective is to determine current through capacitor, voltage across inductor. Since current is flowing like this, the voltage polarities across the inductor will be like this. This is V of t. Yes or no? VL of t. Then VL of 0 plus will also have the same polarities. VL of 0 plus. This is VL of 0 plus. Okay, this is plus minus symbol. And the current direction, already you have the polarities across the capacitor. Therefore, definitely using these polarities, according to passive convention, current flowing here is always IC of t. Now, the IC of 0 plus will also be in the downward direction. Yes or no, all of you? IC of 0 plus. Now, let us look at how to solve it. This is 3 ohm. And your objective is to determine this VL of 0 plus and IC of 0 plus. Now, VL of 0 plus, I can go probably with some touching concept. Okay, I can start from plus and reach minus this way or this way. Okay, but I can go with this way. So, what is the voltage across it? This is plus minus 3 into 5, 15 volts. Okay, 3 into 5, 15 volts. Touching negative sign first. Therefore, VL of 0 plus. VL of 0 plus is minus 15. Minus touching, okay, minus 25. So, minus 40 volts. IC of 0 plus will be, look at this, the current flowing to this path. This path doesn't have any resistor. When there is no resistor in the path, what is the procedure to find current nana? Applying Kirchhoff's current law at this node. Now, if you want to apply Kirchhoff's current law here, you must know the current here is 5 amperes. You must know current here. How much current? 25 by 5. Yes or no? Because the same voltage will appear. 25 by 5. This is 5 amperes. Okay. 5 amperes is entering. 5 amperes is leaving. 4 amperes is entering. So 4 amperes must leave to satisfy Kirchhoff's current law here. So IC of 0 plus is, okay, now 5 plus 4 minus 5. Finally, you got 4 amperes. Now you got here, okay, di of 0 plus by dt. How much? VL of 0 plus how much? Okay, minus 40 by what is the inductance value? 0.25. 0.25 is nothing but 1 by 4. That is minus 160 amperes per second. And dV of 0 plus by dt, okay, nothing but, okay, IC of 0 plus how much here? 4 divided by, what is the capacitance value, Nana? The capacitance value is 0.1. So 0.1 here, the 40 volts per second. Okay, please note down, all of you. Quickly note down. I think you have done this particular part. Okay, you can please carry on with that, and I just note down meanwhile another problem. Okay. Now question number 12. Okay, which was asked in GATE. Question number 12. Please note down that quickly. I just note down the problem meanwhile. Okay. Hope I think you have done with that. Now let's go with the question number 12. In the following circuit, the voltage across C starts increasing with the DC source when the switch is closed. Okay. The rate of increase of voltage across the capacitor when the switch is closed will be at t equal to 0. Okay, at t equal to 0 plus what is the voltage across the capacitor is asking. It's a very simple question. Already we have done RCC circuit. Okay, so let's solve it. Simple one. dVc of 0 plus by dt. The first derivative term he's asking, therefore I told you already the formula simply what is this IC of 0 plus by C. But how do you find IC of 0 plus? Current through capacitor. Other than current through inductor at t equal to 0 plus, you have to go for what? Step 2 only. So step 1, first you construct t equal to 0 minus equivalent. At t equal to 0 minus, he did not mention any voltage across the capacitor. That means it is uncharged. Sometimes he will mention what is the voltage across the capacitor initially also. Before closing the switch, there was some charge. You can ask me, sir, how is it possible having the charge across the capacitor before closing the switch? Yes, it was charged outside and kept in the circuit for a long time. Now the switch is closed. So before closing the switch itself, because it was charged somewhere else, okay, it was charged already. Therefore, you can take that voltage. But now he did not mention anything about that. That means what? By default, it is an uncharged capacitor. Therefore, t equal to 0 minus Vc of 0 minus is what? 0. I use this information to construct what t equal to 0 plus. Okay, voltage across the capacitor at t equal to 0 minus is 0. Nothing but what? Short circuit. Therefore, short circuit resistor, and then you're closing the switch here, and then you are applying the source here, 1 volt, and this is R. Now, what is the current actually flowing through the capacitor? IC of 0 plus. Nothing but, okay, 1 by R. Now, what is dVc of 0 plus by dt? Simply 1 by R by C. 1 by RC. This is the answer. Note down that. Note down that. Question number 13. Question number 12 was asked in GATE. It was a GATE previous question. 13 also asked in GATE. Current through 1 microfarad capacitor T equal to 0 plus is. Simple network again here. Current through 1 microfarad capacitor at T equal to 0 plus is asking. 1 microfarad capacitor, 1 ohm and 5 volts given here. A 2 volt, B 4 volt, C minus 6 volt, D 8 volt. No. The options are not like that. The options are given here: 0 ampere, 1 ampere, 1 ampere, 1.25 ampere, and 5 ampere. Okay, these are the options given. Question number 13 asked in GATE. Current through capacitor. The switch in the following circuit has been closed for a long time. What does it mean? It was in closed position for a long time. It is open at T equal to 0. So what is the current through the capacitor T equal to 0 plus is asking. He did not mention whether the capacitor is charged or uncharged. Okay. So by default you can go for uncharged capacitor. If nothing is mentioned in the problem, it is an uncharged capacitor. Okay. Now let's go with that problem. Solve it. All of you can do it. You can make an attempt. Meanwhile, I will also solve it. Okay. You can do on your own. You also try and also check your answer along when I'm doing here. You can also check your answer whether it is correct or not. You can do parallelly. So step 1, T equal to 0 minus. What is that happening here? Now you need to find voltage across the capacitor, VC of 0 minus. VC of 0 minus is when the switch is closed condition, because you are opening it T equal to 0. That means at T equal to 0 minus, the switch is in closed condition. The capacitor is acting like open circuit. Yes or no, all of you? And your objective is to find voltage across the capacitor, VC of 0 minus, which will help you to find the current through the capacitor. No doubt by looking at the question, we immediately realize, without any delay, we realize that in step 2 only you can get this answer. Yes or no? But to get answer in step 2, you must know what is the voltage across the capacitor in step 1. That is T equal to 0 minus. Now 1 and 4 are connected in series. As soon as the switch is closed and this is open, these two are in series. The voltage across the resistor is nothing but voltage across the capacitor. Therefore, 4 divided by 4 plus 1 into 5. Okay. Therefore, you got 4 volt. You can use the same information for T equal to 0 plus. For T equal to 0 plus, the equivalent circuit is the switch is open and this is completely isolated. You are left with only one capacitor and a resistor. But capacitor T equal to 0 plus is replaced by a voltage source. Yes or no? With a series capacitor model. And you need to go with the current. Actually here, strictly speaking, the current direction must be like this based on the polarities that you determined. Okay, the voltage across the capacitor is how much? 4 volts. Which polarities you are getting? Plus minus. Keeping in mind those polarities, now the direction of the current can be taken as what? IC of 0 plus in the downward direction. Okay, so what is this value actually here? This value is 4 volt and this is 4 ohm. Okay, now since the current flowing through this path, you can find 4 by 4, yes or no? 4 by 4, but that flows in the opposite direction. IC of 0 plus will be definitely minus 4 by 4, that is minus 1 ampere. Minus 1 ampere. But look at these options. You have 0, 1, 1.25, 5 amperes. Okay, but here you got minus 1 ampere. Then how do you really choose the answer? 1 ampere only. Why? Because he did not mention the direction of the current. Just is asking at t equal to 0 plus what is the current flowing through the capacitor. But in which direction he wants, he did not mention. When the direction is not mentioned, okay, you can consider only the magnitude. Understand all of you, okay? Now suppose instead of plus 1 and 0, suppose this option is given minus 1 ampere. Which one do you prefer? Definitely minus 1 ampere you can prefer. Okay, because minus 1 is there, plus 1 is there. That means he is particular about the sign and the direction of the current. But here, no answer is mentioned as such. It is given only 1 ampere. Therefore, I am going to choose this one because he is not worrying about the direction. He is worrying about just only what? The magnitude of the current. Do it. Question number 14. I'll just meanwhile note down. But I think all of you got that answer. If not, just check with the solution clearly. Question number 14 was also asked in GATE. You got the circuit given like this. Three ohm and this is 10 volt. Okay. So what is asking actually in the circuit shown below, the switch S is closed at time t equal to 0. The voltage across the inductor at t equal to 0 plus is VL of 0 plus is asking. Okay. Is closing the switch at t equal to 0. According to the data given, I am just putting the direction here. What is the voltage across the inductor at t equal to 0 plus? That is the question. Okay. So I think all of you completed this part. Note of that circuit also quickly. Now let's go with the solution of that problem. 14th problem. I think you also finished this part. Okay. So voltage across the inductor at t equal to 0 plus. Other than voltage across the capacitor t equal to 0 plus, usually we go for what? Step 2. Yes or no? Step 2. So let's go with the step 2. But before that, step 1 is important. In step 1, you are trying to find current through the inductor and voltage across capacitor t equal to 0 minus. So when the switch is in open condition, initially t equal to 0 minus, switch is open, then can you charge the capacitor? No. So VC of 0 minus is how much? 0. And it is uncharged because it did not give any information on both inductor and capacitor. Therefore, IL of 0 minus is also 0. At t equal to 0 plus, you are constructing the equivalent circuit something like this. The switch is closed, resistor remain resistor, capacitor behaves like short circuit. The resistor remain resistor. Inductor is behaving like what? Open circuit. Here is an inductor physically available. Now this is VL of 0 plus that you are supposed to determine. This is IC of 0 plus, but the question is not asked on the current through the capacitor. It is voltage across the inductor. Yes or no? Okay. So what is that? 4 parallel. and definitely 4 and 4 parallel, nothing but 2. Now this 2 and 3 are in series. The voltage across 2 ohm is nothing but voltage across the inductor. Yes or no? Therefore, VL of 0 plus is nothing but 2 divided by 2 plus 3 into 10. 5 2 ja. Finally, you got 4 volts. Very simple problem. T equal to 0 plus equivalent circuit construction is very, very important. And 99% problems are given based on T equal to 0 plus equivalent circuit only. So that is why you must be expertise in drawing the equivalent circuit at T equal to 0 plus. You should not get confused. You should not do mistakes, I'm telling you. Question number 15, which was asked in GATE. It's an interesting problem. Finish that all of you quickly. It's very, very interesting problem. Okay, so I think you understand all of you. Now it's very clear from the data given, the inductor and the capacitor both are charged. Okay, both are charged. Charged inductor, charged capacitor. This is very, very interesting point to be observed. Okay, they are charged outside and kept inside the circuit. Therefore, they are called charged inductor, charged capacitor. Charged inductor, charged capacitor. This is 10 volts, 10 ohm. Now what is happening? SW2 is closed at T equal to 0. According to the data given, I'm just placing the switch direction like this. SW1 is opened at T equal to 0. Yes or no? So that's why I'm just placing the switch position here. So it is a simultaneous operation. 10 ampere. So this is 10 volt. Now this is 10 ohm. This is R1 and this is R2. So this is what the circuit given. I think all of you. Okay. Question number 15, which was asked in GATE. So what is actually asking? Some options are also given. Okay. Don't worry about the options. Okay. Let us try to practice always without options. Okay. Now, how do you solve it? What is it asking? Current through capacitor and voltage across the inductor. Okay. Current through capacitor, voltage across the inductor. Step 2 only. Other than current through inductor, you have to go for what? Step 2. Other than voltage across capacitor, you have to go for, okay, step 2. Therefore, step 1, first before that, we require step 1. Let me start the problem here. First step 1, what is step 1 actually here? T equal to 0 minus. Okay, T equal to 0 minus equivalent. But what is the objective in finding, constructing T equal to 0 minus equivalent? You would like to find voltage across capacitor and current through inductor. Yes or no? But already you know what was the current flowing here in the inductor before the switching operation. Voltage across the capacitor also is known before switching operation. Therefore, let us take them as it is. Vc of 0 minus is 10 volt and IL of 0 minus is how much? Is 10 amperes. Now step 2. What is step 2 actually here? Let's go for step 2, T equal to 0 plus equivalent using the data given. Okay, understand all of you? Okay, using the data given, that is at T equal to 0 minus, you already know the values. There is no need to construct T equal to 0 minus equivalent. The values were already given. Okay, let us now construct T equal to 0 plus equivalent. How does it look like? So let us do it. Resistor remain resistor. Switch is open, right? Okay, switch is open. Inductor is behaving like what? Inductor is behaving like what? A current source with the value of what? A current source. A current source. What is the current source value? 10 amperes. This is a parallel inductor model. But what is actually required here is asking the voltage across the inductor. Understand all of you? Okay. So how do you find the voltage across the inductor? This is plus, this is minus, let us say. Okay, this is plus, this is minus. You want VL of 0 plus. Now, next, another one is close the switch. This is 10 ohm. What about this capacitor? Capacitor is something like this. This is a capacitor. What is the current flowing through the capacitor here? IC. How do you know the direction of the capacitor current? Because based on the polarities given. Based on the direction of current given, polarities are placed. Based on the polarities are given, current direction is placed, because both are passive elements. According to passive convention, I have placed the direction as well as the polarities like this. What is the value here? 10 volt. Clear, all of you? This is 10 volt. Now, you would like to find these values. How do you find? Just simply solving the network. When you have multiple sources, obviously you can go with node analysis. V of 0 plus of 1 by 10 plus 1 by 10, right? 1 by 10 plus 1 by 10 is equal to plus 10 plus 10 by 10 plus 10 by 10. This is 1. So this is actually 2 by 10, 1 by 5. So V of 0 plus is what? 5 into 11, 55. V of 0 plus is, okay, 55 volts. Understand, all of you? Okay. So what is VL of 0 plus? VL of 0 plus is, okay, V of 0 plus is what? Actually here 55 you got it. But what is VL of 0 plus? You get here, that is minus 55. Okay, minus 55 volts. Now what about IC of 0 plus? IC of 0 plus is V of 0 plus minus 10 by, yes or no? Minus 10 by 10. So what is that? 55 minus 10 by 10. 45 by 10, that is 4.5 amperes. Yes or no, all of you? Okay, 4.5 amperes. Then finally you got VL of 0 plus minus 55, IC of 0 plus 4.5. But look at the options given. Options are given like this. Option D, when you look at current through C and voltage across L at T equal to 0 plus is option D is given. What is that option D actually here? Option D is given as 4.5 amperes, comma 55 volts. But look at this. What is the voltage across the inductor? Is it 55 or minus 55? Minus 55. But he is not mentioning the voltage across the capacitor with polarities. He is not asking with polarities. He is not worrying about the polarities. Okay. And options also, if you go through that, there was no option given with minus 55 volts. Therefore, let us ignore this sign to answer that question. Okay. And keep it as 55 volts and 4.5 amperes as it is. Go with option D. Understand, all of you? Okay, go with option D. This is how you need to construct, as I told you. Note on that. Meanwhile, I just note on the question here. It was asked in GATE. $20 ohm, 5 Henry, switch is open at T equal to 0, 2.5 ampere, 20 volts, 20 ohm. It's very simple network. It is also very simple problem. It's just asking what is Vx of 0 plus. What is Vx of 0 plus?